Hello. So I want to continue on the videos on how to remember so many trigonometric equations. Some other equations that you're meant to remember in trig are double angle formulas. And so those are, sine of, let's say, 2x, cosine of 2x, and so on. So to remember these, really, we just need to know kind of two things, right? We need to know our addition and subtraction formulas. So I listed those in the last video, but let's put them here again. So addition and subtraction formulas. So if I have sine of alpha plus beta, that's going to be sine of alpha cosine of beta plus the sine of beta cosine of alpha. And if it's a minus, then it's a minus on this side. And the same, well, kind of the reverse for cosine. So cosine of alpha plus beta is going to be cosine of alpha cosine of beta minus sine of alpha sine of beta. And then if it's a minus, then it'll be a plus. So I just wrote it this way for compactness, just so I can fit everything on the board at once. So we have our addition and subtraction formulas. The only other thing we need to know is our Pythagorean identity. And the one I'm going to use is sine squared plus cosine squared is equal to 1. So now let's look at these equations. If I have sine of 2x, that's the same. So the sine of 2x is the same as sine of x plus x, right? X plus x is 2x. Now we need to use our addition formulas. So sine of alpha plus beta, doesn't matter if they're the same thing. So sine of alpha plus beta is going to be sine of alpha cosine of beta plus the sine of beta cosine of alpha. So these guys are the same, right? So this is just 2 sine of alpha cosine beta, or sine x cos x. And that's what this is. So that's our first double angle. For the second, we're going to do just the same thing. We're going to plug this into our addition formula. So this is cosine of alpha cosine of beta. And remember, if I'm adding two angles, then I need to subtract. In here, sine alpha sine beta. So what does that give me? Well, it's cosine of x times cosine of x, so that's cosine squared of x, minus sine of x times sine of x, so that's sine squared of x. So that's almost it, but for those of you that have looked ahead or are currently in this section, you know that there's usually 3 listed here, not just this one. So let's play around with this Pythagorean identity. So sine squared plus cosine squared is equal to 1. So that means that if I subtract sine squared from both sides, I'd have cosine squared of x is equal to 1 minus sine squared. Right? So let's try that over here. Cosine squared of x is equal to 1 minus sine squared. So this is the same as cosine squared of x is 1 minus sine squared. And I'm already subtracting off a sine squared. And so I get 1 minus 2 sine squared. So that's another way we can write it. And similarly, using this Pythagorean identity, if I subtract cosine squared from both sides, I'll have that sine squared is equal to 1 minus cosine squared. So let's try that over here. I'll have, so cosine squared is going to stay the same, minus, and then sine squared is the same as 1 minus cosine squared. So I'll have minus 1 and then plus a cosine squared. So 2 cosine squared x minus 1. So it's kind of busy over here. So this is the first one we got, just using our addition and subtraction formulas. This one we just use a substitution with our Pythagorean identity, and the same thing, substitution with a Pythagorean identity. And those are the three equations, or the three expressions that are equivalent to cosine of 2x. And then for the tangent of 2x, just remember that it's sine of 2x over cosine of 2x. And I think that you can go ahead and derive that, and if not, I'll make another video. So I hope that helped. Thanks, guys.